Alright, hello again. We're going to squeeze another problem in. We're doing problem number 23 on page 534. This is chapter 7.8. I'm trying to do a lot of these problems because it'll test our other skills as well as also show some improper integrals. So the first thing that we always want to do, we want to check to see whenever we have a definite integral. Alright, we want to see if we can find any discontinuities. And check the length of our interval, i.e. we want to look for the infinity symbol in the upper or lower limit. So it's certainly going to be improper, as our interval, right, is from 0 to infinity. Anytime we see an infinity symbol, we're thinking improper. Our discontinuities, well, z squared plus 4 is always strictly positive, so there's none. We have no discontinuities. So this problem now becomes the limit as t approaches negative infinity, the integral from t to 0, z over z squared plus 4 dz. Now, in the previous video, I did all of the steps at once. I kept the limit around. Tried to keep track of all of our limits and computations all in one. But now I'm going to do something that one of the other professors does. We got to remember our steps. So she solves the problem as a definite integral in t first, and then takes the limit. So that way it becomes just a 7.1 through 7.4 problem, or a Calc 1 problem, and then she applies the limit after, so that is a Calc 1 problem, like Chapter 2 problem. So she breaks it down into much smaller steps. I think it's a good idea. I'm going to try it and see if you guys can follow it a little easier. So step 1, let's give ourselves some space here. So step 1, we're just going to solve the definite integral, t to 0, z over z squared plus 4 dt, dz, jeez, there we go, dz. This is disgusting, let me rewrite it. Okay. Alright, now, z squared plus 4 is not, let me make sure I'm doing the right problem here. Yep. Sorry, z, that's why. I was like, this is a different problem. Alright, hold on. Z to the 4th. It's getting ahead of myself. Problem is z to the 4th plus 4. Okay. Now, z to the 4th, we don't know how to factor, I don't know how to factor quartics. I'm sure someone does. But we do know integrals of the form of 1 over x squared plus a squared. We know integrals of this form. Okay? So that idea, alright, well, we want to think of z to the 4th as just z squared squared. Okay? So we're going to try to make it look closer to that. We're going to try to make it look closer to the integrals that we know already. Okay? So what we're going to do, and again, I say this often in class, but if you're not sure, we want to do something. We think z squared is good. Okay? So let me just take the step and go t to 0 of z over z squared squared plus 4 dz, and hopefully we should see our next step. Okay, because down here in the denominator, alright, we have a z squared. Well, the derivative of z squared is z, so this looks like a prime opportunity for u sub. So what we're going to do now is we're going to say u equals z squared. That helps because now I have an integral of this form, and I have an integral of just x squared plus a squared, or in this case u squared plus a squared. Okay. du is 2z dz. So 1/2 du equals z dz. Now let's check our limits. I plug in 0 for z, I get 0. I plug in t for z, I get t squared. Okay. So now that gives us a new integral, t squared to 0, 1/2 from the differential, du over u squared plus 4. All right, this is great. This is now just a formula, right? Let's recall 1 over a arctan x over a. So we're going to get, this is 1/2 times 1 over 2 arctan u over 2 from t squared to 0, which is going to equal 1/4 arctan of 0 minus 1/4 arctan t squared over 2. Okay. Arctan of 0 is going to be 0. So this is 0 minus 1/4 tan inverse of t squared over 2. Okay. Now we're going to do step 2. Solve the limit. Because recall, our actual integral is from negative infinity to 0 of z over z to the 4th plus 4 dz. And we said that's the limit as t approaches negative infinity of negative 1/4 arctan of t squared over 2. All right. Remember arctan. Let's do this even better. Recall right. Arctan goes between negative pi over 2 and pi over 2. So t is going to go off to negative infinity. That means t squared is going to go off to positive infinity. So I'm taking arctan as I let t get arbitrarily large. My arctan is going to go off to pi over 2. Okay, so this is going to equal negative 1/4 pi over 2. Okay. Now, let's think about this a little bit. Remember, we're on 0 to negative infinity. This is negative. This is positive. A negative divided by a positive. All right. If this thing converges, a negative divided by a negative is negative. This whole thing should be less than 0. It makes sense. It checks out. Okay. Now let's go ahead. See if I can graph it real quick for you as well. I think this is an important step that you always want to do. it's so helpful just to make sure that because you're going to work fast. Like, I think this is going to be a long exam. You're really going to have to work fast. All right. So here we go. This is the piece that it looks like, from like -1,000 to 0. Okay, this is some weird computation error. Look, these numbers are very near 0, right? -1 times 10 to the -7th, etc., etc., etc. Like, that's just a sort of computation error from Wolfram Alpha. Let's look at the whole thing, both positive and negative arches. Again, just like we thought, bang, positive on the right half, negative on the left half, so our answer should be negative. That's good. Our sign is great. All right. And then we're just gonna check. There you go. -pi/8 confirmed. Normally we wouldn't need to do that, but since I'm not really on my A game, I figured we should double check. If you really need to. Right, this is -pi/8. I would accept either answer, but there you go. We nailed it.